Hey guys, this is Coach Brian bringing you part 4 of your final exam review. From this part on, this is ones that we have worked in class, so hopefully you already have these done, but just in case you don't or you need a second explanation, that's what these next 3 videos are for. So for question number 15, we're looking at parametric equations. Remember, they're just measuring two things that are happening simultaneously. So the kind of key words in here are that it tells us to find the ordered pairs. So we should be getting an X and a Y from everything. And we're looking for position. So that shows us where something is. And then we have at time is -4 and time is 3. So we're trying to find an X, Y for both of those. So when we have a time, we need to plug it into our function, and we need an X, so we need to plug that time into the X, and we need a Y, so we need to plug that into the Y. So for the first one, we would start with -4 plus 7. -4 plus 7 is 3. And then we would plug in -4, square it, and subtract 9. A negative squared is a positive, and then 16 minus 9 would leave us with 7. So our ordered pair at time equals -4, the position is 3, 7. So for the next one, we need at time equals 3 an X and a Y. So we need to plug in 3 here as the t. So 3 plus 7 is 10. And then we would plug in the 3 here. 3 squared is 9. 9 minus 9 is 0. So we have our two ordered pairs. At time equals -4, we're at 3, 7. And at time equals 3, we're at 10, 0. The next few are definitions. We are looking for the definition of ellipse, circles, parabola, and hyperbola. These all come from the 10.2 notes. So if you're looking for these, that's where they are located. They all start with the same kind of key words. The set of all points on a plane. So if you want to just maybe write that once, and that's kind of your introductory statement for both of these, the set of all points on a plane. So for an ellipse, it's the set of all points on a plane for which the sum of the distances, to two fixed points, those two fixed points are the foci, the focus points, is constant. So in Schoology, I've included some links for all of these visualizers. And if you go to the Semester 2 exam folder, you'll see an ellipse visualizer, parabola, hyperbola. And if you're trying to make sense of what these definitions mean, on an ellipse, I can move this point, and these two lines, the one that goes to focus 1 and the one that goes to focus 2, their sum, if I add them together, is always a constant. So you can see on this one, like, see how PF1 plus PF2 equals 16? No matter where I move around this ellipse, those two things in combination equals 16. So that's what the definition of an ellipse means. It says when you add, or you get the sum of these two lines that go to the focus points, the foci, then they add up to a constant. And in this case, that constant is 16. So going back, I'm going to go over the other definitions, but just so I can show you now, I also have these for a parabola. In a parabola, excuse me, the distance from the parabola to the focus and the parabola to the directrix is always the same. See how it gets, as you get right on the line there, it becomes that value of P, and they equal out, and then you can kind of expand up the side. And those two lines, sometimes it really doesn't look like they are, but they are equal at every point on the parabola, okay, at every point on the parabola. And then lastly, I put in a hyperbola. And for the hyperbola, very similar to the ellipse, but instead of the sum of the sides, it's the difference of the sides equaling a constant. So as I move this point, I can take the line that goes to A and the line that goes to B, and they should always have the same difference. If you look in the little box right here, it says PB minus PA is 2. And that's true no matter where I go. It's finding the difference. If I take PB and subtract PA, the difference should be 2 no matter where I go. And you can see that's true all the way around. So that's where these definitions come from, or it's at least a way to visualize them. So for an ellipse, we said the sum of the distances is constant. We didn't go over a circle a whole lot, but it's because a circle is the one you're most common, or you're most familiar with. But in a circle, it's the set of all points on a plane where all of the points, every single point on the circle, all points are equidistant, meaning they're the same distance from a fixed point, and on a circle, that fixed point is the center. And the center is marked with the coordinates HK. Parabola, which I also just showed you, it's the one where the line, if you put any point on the parabola, you can go from there to the focus or there to the directrix, and it should be the same. So for this one, we'd say this is the set of all points on a plane for which the distance to a fixed point, the distance to a fixed point, and remember we call that fixed point the focus, and the distance to a fixed line, which is the directrix, so the distance to the focus and the distance to the directrix are equal. And then lastly, the hyperbola, which is the last one we looked at. It's the set of all points on a plane for which, and like I said, this is very similar to the ellipse. The ellipse, it's where the sum of the distances is constant. Here we would say for which the difference, which implies that you are subtracting them, the difference of the distances to two fixed points, the foci, is constant. All right, we have 2 more problems left on this. 17 says sketch the ellipse, labeling the center, vertices, co-vertices, and foci. So again, this comes from our 10.2 notes. So if you need to, go back and check those out. I'm gonna move through this kind of quickly. The first thing you want to do is you want to see which one of these 2 numbers is bigger. 25 is bigger, which means it's our A value, and 9 is smaller, which means it's our B value. So I just like to keep a running list over here to the side. If A squared is 25, that means A is 5. And if B squared is 9, that means B is 3. And now the next thing I like to do is go ahead and find out what my c value is. It's going to be the square root of the difference of a squared minus b squared. So in this case, a squared is 25, b squared is 9, which means it equals the square root of 16, which is 4. So c equals 4. So I've got the 3 distances I need to graph an ellipse, my a, b, and c. The last thing I really need to get is my h and k. Now, h is always in parentheses with the x, and k is always in parentheses with the y. Now, x minus h is what the original formula says. It says x minus h. And so what we've got here technically is x minus positive 4. And on this side, we've got y minus, well, how did it become a positive? It's because it's actually minus negative 3. So our h is positive 4, our k is negative 3. So our center is located at 4, negative 3. 4, negative 3. So once I find that, I've got everything I need to go ahead and graph this ellipse. I'm going to go ahead and mark the center at 4, negative 3. And then since the bigger number a is under or, associated with k and y, that means this is a tall parabola. Y and k always have to do with the vertical. And since our biggest distance is on our vertical side, that means this is a tall parabola. So what that means is my a value, this 5 right here, I'm going to count up from my center, 5, 1, 2, 3, 4, 5, and mark there. I'm going to also mark down from the center, 1, 2, 3, 4, 5. Since I'm on this major axis, I can also go ahead and mark my c value. It's 4, so I'm going to go from the center 4, and I'm going to go from the center 4, and those are my foci. And then I'm going to go to the minor axis, which will be this way, and I'm going to mark my b values. So I'm going to go to the right, 1, 2, 3. I'm going to go to the left, 1, 2, 3. And then I'm going to connect these with an ellipse. I wanted that to be a different color. And the ellipse, not going to be perfect. I shouldn't have picked this dotted line if I was going to trace over it. But it's kind of this like oblong circle. You can perfect it a little bit as you go. So that's our ellipse right there. Again, as you kind of draw it, you can make the curve smoother. I'm just making this worse. You can make the curve smoother. My hand keeps slipping off my iPad and messing it up even more. So you've got kind of this like oblong circle, this kind of almond-shaped ellipse. And then we need to find out the center, the vertices, the co-vertices, and the foci. So the center is at HK, which is 4, negative 3. The vertices, which are, they're your A points. So if I mark them again over here, it's the 2 pink points. They should be in line with each other. So the taller one is at 4, 2. And the lower one is at 4. They're on the same x. If you notice, they're on the same x. It's at 4, and it's down at negative 8. Then our foci are also going to be on that same line. So they're both going to be at 4. But they're only 4 from the center, so we go to 4, 1. And then we would have 4, let me make that a little, 4, negative 7. So they're also on the same x when you have a tall ellipse. And then lastly, we have our co-vertices, which are the blue points. So The first one is at 1, -3, and the second one is at 7, -3. So if you notice, for a tall ellipse, these have the same y. They have the same y value because they're at the same height. All right. Question 18 says to graph the parabola. There's a lot of kind of like information hidden in here as well. First, we've got the x as the thing that's being squared. Okay, so that lets me know that this is a upright parabola, so it's going to look like one of these. By that I mean it's not on its side. Okay, it's not on its side. It's going to be one of these two. It's either going to open up or open down. Second, always with the x is h. That means with y is k. So that's important because that's going to be my vertex. And then this value in the middle is 4p. So really that's all we need to go ahead and figure this guy out. The x minus h lets me know that my h value is +5. And over here, the y minus k lets me know that my k value is a +4. So that's where the vertex of this is. It's over at 5, 4. Next, the axis of symmetry. If you look back at your notes for this lesson, on a parabola that is tall or upright, up or down, opens up or down, the focus, or excuse me, the axis of symmetry is at x equals h. So all we need is our h value, and we would say x equals 5, and that would be our axis of symmetry. So if you wanted to, you could go ahead and put a kind of a dashed line through the center. Your parabola is going to reflect on both sides of that line. We've got our p value, which is the distance from the vertex. It's going to be the distance to the directrix, which is the line that could be above or below it. And it's also going to be the distance to the focus. And so we know that -12 equals 4p. So if we divide both sides by 4, p equals -3. That's our p value. P equals -3. So that means from this vertex, we're going to go up 3, 1, 2, 3, and that's either going to be our focus or our directrix, and we're going to go down 3, 1, 2, 3. That's either going to be our focus or our directrix. Now, since this is negative, that means our parabola opens down. It opens down. Now that helps a lot because it now lets us know that our directrix is going to be up here. And it's going to be at y equals 7. Because it's at a height of 7, and it's a horizontal line going through that height. And then that means our focus, we now know, is this point down here, which is at 5, 1. And if you're using your notes, you could still calculate the focus. It says it's h, comma, k plus p. And so if you use your h, that's 5. Your k is 4. And if you added p, which is -3, it would give you 5, 1 anyway. So you can either get there by graphing it out and plotting the points, or you can get there mathematically too. And then lastly, we've got our focal chord length, which is the absolute value of 4p. So we know that 4p is -12. So it'd be the absolute value of -12, which is just 12. Now, what does that mean? It means when you go through this focus, the line that goes through it is going to have a total length of 12, which means I can count 1, 2, 3, 4, 5, 6, and that's one of my points on my parabola. And then I can actually go 6 the other way. 1, 2, 3, 4, 5, 6. I know I kind of get off of the grid there. And then lastly, now that I've got all this plotted, I can just create my smooth curve that crosses through the vertex and the focal chord, or the points at the end of the focal chord, and that gives me my parabola. So hopefully this helps you as you work 15 through 18, and then I'll probably combine the last 2 pages, 19 through 22, into one last video. So good luck studying.